Hi, I started Final Homework by loading a series of libraries that I used, mainly the tidyverse package, and a library for displaying tables, as well as a library to quickly display correlations. So problem 1. I started off by defining the two random variables, x and y. I picked n to be equal to number 8. Here is x, a uniform random variable, and y is a normal random variable with standard deviation and mean as given by the homework. So then I did probability. Started a calculation on little x and little y as indicated, then solved each of the cases given. So I calculated x and y. For A, I used conditional probability so that the formula I calculated each component. This is the formula right there. Probability of x greater than little x and y greater than little y. And the probability that x is greater than little y. And then divided both to get the result. For B, I calculated the joint probability by adding all of the samples that meet the condition, and then divide it by n. On C, was calculated in a similar way to A, basically the same formula. For independence, I analyzed this by computing the contingency table here shown with counts. To obtain this table, the joint and marginal probabilities were computed, so both tables are equivalent with probabilities and counts. Now, assuming the dependence, we compute the probability as the product and compare against this table, where the same probabilities will computed, not assuming the independence, but rather by adding all of the samples and observations from the first table. We can see here how, in fact, we get the same results. I rounded out to 2 decimals. And although some of these logical comparisons show false, if you, in fact, run the simulation several times, you will eventually get similar results. The differences are just very, very small. Finally, I did the Fisher and the chi-test. Both show pretty high p-values. So the null is not rejected. The null hypothesis stated independence, so we obtain the same result, basically. The difference between these two tests is how they perform under more or less samples. I had to use non-default setting on the Fisher test to get it to work with these number of samples. Basically worked with smaller amounts of samples. So moving on to problem 2, which was actually pretty fun. First things first, downloading the data and loaded all of the labels from all of the columns and features to familiarize with what was at hand. So basically just displaying the column names. Then I plot a histogram for all of the numerical data, which gives us an idea of what might be useful. To look at discrete statistics, I actually use 2 different functions. First, I use the summary data on the data set. That gives us good means, medians, minimums, max. But I also use the summary function. And this one's pretty cool because it gives us an idea of nulls and missing data on all of the data sets. For detailed scatter plots, I basically looked at 2 interesting ones. Lot area and garage area. Interesting unfortunately, the biggest lots with the biggest garage are not the homes with the highest prices. We actually see some of the highest prices around this area. Second, I looked at area and lot area and the basement area. The thinking was that a bigger lot, bigger basement, maybe. But so if there is that correlation, that'd be a good segue into the next step, or correlation. Here I picked a few features and plotted the matrix using one of the libraries that I downloaded. Interestingly, not much correlation between that basement and lot sizes as I suspected when I picked the scattered data, that plot. So here I looked at sales price and lot area using the core test function. I easily calculated the confidence interval for the hypothesis testing. It's basically just one function. And it resulted in a very low p-value. So for that 80% confidence level, basically for the first one I got 0.18 to 0.24. Did the same for sales price and basement size, and also for lot area and basement size. So as far as type 1 error, which is basically what the family-wise error is, I'm not very concerned. The p-values on both of the first two plots are very small, so pretty much any threshold alpha would give the same result. There's really no concern in picking it wrong. Then linear algebra. This section was rather straightforward with the tools that were given during the semester. Inversion was calculated using the solve function. Then multiply matrices using the operator. For the LU decomposition, I decided to use a function that I wrote on one of the first assignments, assignments 2, at the start of the semester. And finally, comparing the multiplication of L and U to make sure that I ended up back with the same matrix. So I did the logical comparison right here. Well, after doing the rounding, I got true, basically the same matrix. In calculus and statistics, I used a given function to calculate an exponential model, as was given in the instructions using this mass library. Then generated this is the exponential. Then generated a normal model and plotted the original data as well. Compare again the exponential and the normal model. Then I actually did the normal model and compared all three. What I found was that the normal model was actually a better fit than the exponential. So the data that we were supposed to pick at the very beginning was supposed to be right skewed, and I thought it looked right skewed, but it turns out that a normal model is a better fit. Then finally, the modeling for the Kegel composition. So first I selected a list of features using the exploratory analysis from before and plotted these features against sales price. So those are these plots right here. Sales price being the independent variable that we want to be able to predict. Then ran a model with a subset of features. It looked fairly good as far as residuals goes. But several variables had pretty low p-values, which basically tells me that they're not very relevant. So ran a second model without those variables, and obtain again a variable, model with pretty good residuals. But I actually ran a third model, eliminating some other features from it. Basically eliminating one more, but basically got the same results. Looked at a correlation between the different features, looking for some high correlation to see if some other feature I wouldn't want, and did the same thing with the third model, and ended up selecting the second model. In reality, both results were very similar. I generated the prediction shown on this table. You can scroll on the table using one of the libraries that I brought in. And finally, simply formatted the data the way that the Kaggle website requires it. I had to eliminate or handle the NA, the null values. The Kaggle requires the same number of observations, so instead of just eliminating the NAs, I substituted them with the medium, and I submitted it, and I got the score right here, and that's basically it. Thanks a lot for the course. I really enjoyed it.